plot, as you can see, REQ and XEQ. From the pattern difference, we can identify what it's healthy or not. Then we can also identify its rotor fault or its high resistance contact, or we can tell stator core fault.
Oh, I get it. Yeah, it's offline testing, so the wind turbine should be shut down. It should be separated, disconnected from the grid first, right?
Not exactly. The wind turbine doesn't have to shut down. In practice,
just disconnected from the grid.
Yeah.
All right.
Since that condition is normal condition of the wind turbine when it's standby. The wind turbine is almost 70 or 80%. 80% of its operation time is of working. The remaining, remaining 20 or 30 times remain standby.
Yeah.
So there is plenty of time, I think.
Yeah. Okay, I get you. Another thing is there were 3 types of the faults, and the 2 and 3 looks pretty similar, even though the third one is quite smooth, but it should be quite difficult to distinguish, come up with the criteria, which one is the second, which one is the third type of the fault. So how you manage that?
Yes, that's true, but first we can distinguish between those 2 faults by using this, let me show you using this pattern in the REQ and XEQ. Second, we also have an additional distinguishing factor, which is based on the comparative angle in the rotor circuit. When there is a fault in the rotor circuit, that fault will be always in the same pace with regard to the rotor circuit, because it's in the rotor circuit. That fault is in the rotor circuit. And second fault is located in the stator core. If we rotate the rotor, that fault will not change in shorted rotor turn graph, but it will shift. Phase will shift in the shorted lamination.
Right. So you also have some criteria rather than this equivalent resistance.
Yes, we have, but I didn't include in this estimation.
Oh, okay. Okay. The last question is what's the drawback of this identification method to implement in a real wind farms?
Yeah, I think the problem would be the installation or reprogramming of the inverter, since that D5G inverter program, or the let's say owner right. It's maybe related to the owner or the company who manufactured that inverter. So the main problem could be the right to change that algorithm. But I think that could be main problem. Otherwise, the programming or adding this external algorithm could be easy. But right to the changes could be a little bit, legally could be a little bit difficult. We have to maybe take permission from the manufacturer or the owner, or something like that.
Okay. But the inverter's got a capability to perform this kind of pulsating current?
Yes, 100%.
Okay, thank you.
Yeah, thank you for the questions. Any other questions?
Thank you for your presentation. You said your proposed method reduced the maintenance cost. So, did you measure
No, exactly. The reason we are claiming it could reduce the maintenance cost is currently for these faults, like rotor turn fault and also stator core fault, those faults really hard to detect, because the online monitoring now in the field use these based on the the frequency when that's taken by the measuring instruments when wind turbine is operating, which has a lot of noise. So because of that noise and also low frequency in the rotor circuit, the faults are very hard to detect. And so the only reliable test methods are to send a person or technician to wind turbine, and when during the standby, that technician has to disconnect some rotor circuit from the system and then do some measurement. That cost is that technician labor of the technician, also the transportation for especially for the offshore wind turbines. Yeah.
Okay, thank you.
Thank you.
Okay, thank you for your interesting presentation. I would like to know where did you carry out your test? At the laboratory or at
Yes.
the wind turbine?
Yeah, we did that experimental result from obtained in the laboratory.
So then you made some fault for the generator. And
Yes,
then
yes.
you identified it. Okay. And as I see, there are three kind of fault you show for us. And is there any other fault in generator that your method may be useful for detection?
Yes, I think there could be one additional fault we can detect, which is rotor circuit, open circuit in the rotor circuit, which means one of those one of the three parallel circuit could be disconnected because of the fault, like shorter term fault. When shorter term fault happens, there will be much more heat will be produced, and that heat can melt down the winding. So there could be disconnection, and that fault can be also detected by this fault test method. Yeah.
Thank you.
Yeah, thank you for the question.
Thank you so much, Mr. Very interesting. Okay, the next presenter.
Thank you very much.